So 8.1, 5.0, and 8.2, those are in the grade book. Those are part of the third 9 weeks, and that's on your little grade sheet, okay? So here's the encouraging thing. Your grade can't go down, so it can't get any worse than it is now, okay? You have till Friday. Which one? Okay, did you do the front side all?
I'm doing it.
Just do the front side and turn it in. Okay. So for my class, and in all reality, everything's due Friday. Your other teachers might ask for it sooner. It would be nice for y'all to turn it in sooner, but everything is due Friday for sure, like deadline live. If you don't turn it in by Friday. Wait, I want less interrupting today. Okay, thank you. So these 3 need to be turned in. Do you see the ones that you have to do? 1 through 14 on 5.0, and then 1 through 7, 9, 10, and 12 on 8.2. Now, when are grades due? Friday. And I need less of that, like forever. So, again, grades are due Friday. So Friday is the last day for new grades. Another thing, some people are low-key borrowing calculators and bringing them back. It's better if you talk to me before they leave the room because I need to keep a record of that, especially if you accidentally take it or even purposely take it for malicious reasons. Please bring it back. I need those. I'm down a few, which is not good for me, which is not good at all, okay? Meaning they're missing, so pretty sure that might be 8th period, but we'll see. So, not this period. Now, if you turned in last week's warm-up, cool. If you didn't, make sure you put sub for Friday. And yes. Now, this question looks maybe simple enough, but can you add these 3 fractions? Okay. Yes, you can. But the question is, can you do it right? Now, who thinks you just add up the top and add up the bottom?
Wait, don't you just do
What?
everything to the bottom when it's just the biggest number, right? Or,
It could be that.
right.
Sometimes. Not every time.
Okay.
Okay. So here's the deal. These do not just add the top and add the bottom like you do when you're multiplying. Okay. So last unit, which was 8.2, that one you just multiply top, multiply bottom. But this one has a special rule. Now, the only way to add fractions is if they have the same denominator. Which side is the denominator, up or down? Down. Denominator. Denominator. Okay? So, do these have the same denominator, 2, 4, and 8? No, they're obviously different numbers. So what you need to do is you need to transform these into the same denominator. So, the way we do that, have y'all heard in your youth, in your younger youth, something called the least common denominator, LCD, or least common multiple? Y'all heard that word before, that phrase? Okay, so least common denominator is basically saying what number on the bottom do all 3 of these numbers go into? So what does 2, 4, and 8 go into? I'm not asking what their factors are below them. I'm asking what do they go into? What's a bigger number 2, 4, and 8 go into?
16.
Okay, so 16 is true, but that is not the least common denominator. 2 is too small because 8 does not go into 2. 8 does not go into 4 either.
9.
That's too big. What?
9 isn't even big.
8, thank you. So, everybody.
That's
So-
what I said.
Yeah. So, sometimes it's bigger than these 3 numbers, but sometimes it's one of these numbers, okay? So, check it out. 8 goes into itself, 4 goes into 8, 2 goes into 8, okay? So, here's what you got to do. You got to multiply these fractions until they all have the same bottom, same denominator. So, what would you multiply 2 times to get 8? 2 times 4, right? So, here's what you're going to do. You're going to take this 1/2 and multiply all that times 4. 4 on the top, 4 on the bottom. So, that gives you 4 over 8. Does that make sense? That 4 over 8 is equivalent to 1/2. They're the same fraction, just they look different. Okay. What do I multiply the second one to get 8? Okay, so all this times 2, which is 2 over 8. Okay, remember we're adding. Now hold on. This already is 8. So it's leave it like it is, plus 1 over 8. And now we add them all up. And what do we get? 4 plus 2 plus 1 on top gives me 7, but the denominator stays the same, okay? 7 over 8. So, yes, it does. So the denominator stays the same because it's like the name.
But it won't always be like that for every scenario?
It gets more complicated, but it's the same idea. The bottom has to match, then you can add. Okay? Now, by the way, have y'all ever heard the phrase denomination? Okay? Denomination is just a name. So when we talk about the denominator, that's the name of the fraction. These are eighths. You can only add eighths together. I can't add halves with eighths because they have a different name, different denominator, different denomination. Right? Okay? By the way, and that's it, 7 over 8. Now that's a simple explanation of this. We're gonna take it easy at first. We're gonna ramp up into using rationals with variables with polynomials. Woo! This gets spicy in a minute here. So.
Spicy.
Yeah. Here we go. 8.3. By the way, this is part of fourth 9 weeks. Fourth 9 weeks, real quick because it's brand new. Fourth 9 weeks is, it's like the fourth quarter. You want to make sure you do really well. Okay, so. Boy. I was listening to that on Friday. All right, now, think of the warm-up, think of how we did it, and look at this problem. I want to find the LCD. Let's go ahead and write that down somewhere. LCD, or least common denominator. Least common denominator. Or LCD. Now, first of all, that 5 is a whole number. Whole numbers are always over what? Over 1. So if you want to just put it over 1 or you want to rewrite it like this, either way, you need to know that that last fraction is over 1, right? Put it that way. Like, I don't know, like away, like. Or like. Okay, now, what is the least common denominator of 3, 6, and 1? What do all three of those numbers go into? What? 6. 3 goes into 6. 6 goes into itself. 1 goes into 6. So what we need to do is find the multipliers. What do I multiply the first one by to get 6? Okay, times 2. So it's going to look like this. What about the last one? Times what? 6. Now, all you got to do is do the math. So the first one, 2 times 4 and 2 times 3 gives me 8 over 6. The last one, 5 times 6 and 1 times 6 gives me 30 over 6. So now I got 3 fractions. Okay. And now that the denominators match, I can add them all together, right? Cool. So add them up. What do we get? 39 over 6. Is that what y'all got?
So you don't add the bottom?
Correct. It's like the name. The name of it stays the same. 8 sixths, 1 sixth, 36. Okay. You could change that 6 to some term, some noun. 8 points plus 1 point plus 30 points gives you 39 points. Okay. The bottom stays the same. We do need to simplify it. What does 39 over 6 reduce to? Either you're good at reducing, or you can type it in your calculator and press enter and it'll do it for you. Yes? 13 over 2. Close enough. Not really, but. All right. So again, these both divide by 3. 39 divided by 3 is 13. 6 divided by 3 is 2. Okay. All right. Wait, what? Oh, on the next one, no. X is not. Okay, by the way, I hear this all the time. X is not 1. There's a 1 in front of X, but X is X.
So 1x.
Sure, but it's not just 1. All right, look at the next one. Example 2. Look at my denominators down on the denominators, right? 8, 2, and 4. What does 8, 2, and 4 all go into? 8. 2 goes into 8, 4 goes into 8, 8 goes into itself. So what are my multipliers going to be? So this first one is already 8. The second one has to multiply by what to get to 8? It is 2. 2 times what is 8? 4. Okay. Hey, where'd you get this? All right. So the first one is 8. The second one times 4 gives me 8. What does the last one multiply by to get to 8? Times 2. Okay. All right, does everyone see what we're doing? We're trying to get 8 on the bottom, right? So let's do the multiplying. 5 times 4 is 20. 3 times 2 is 6. This is not too different than the first one. But what is different about this one?
X.
We have an X. Who else has an X? All right. Don't think about it. All right. Now, what do we do next? We need to add, right? So here's the deal. X cannot add with the numbers. So what we do, now we're back to variables and math, right? So we can only add the constants. 20 plus 6 gives me what? 26. The x is going to stay there. So you have x plus 26 on top. So the x stays there. The 20 plus 6 gives you 26. Those cannot combine because they're different. 8 stays on the bottom. It happens, you know. Now, that's it. Questions on that one? Don't combine things you cannot combine. That is basically, I do not want you to think this is 26x. That's multiplying. No. Okay. Ready for example 3? Ready or not? Here we come. So, now let's talk about when we have x's. What do you think the least common denominator is between 3x and just x? So x, they have x in common, but 3x does not go into just x.
Gotta add it.
X goes into 3x. Does 3x go into 3x? So if they share an x, pick the one that has the coefficient in front. So 3x is the least common denominator. 3x goes into itself. X goes into 3x 3 times. Okay? So check it out. If we multiply the second fraction by 3, well, we have matching denominators, right? This 3 times x will give you 3x. That matches. On top, we have 4 times 3. We get 12. Now that we have matching denominators, let's add those numerators on top. 2 plus 12 gives me 14 over 3x. Okay? Whoa, what's up? Don't ask me a question. What's up? It's actually the smallest number that both denominators go into. Not always. So let me give you an example. 1 over 3 plus 1 over 5. Okay? What's the least? Hey, you asked a question. Listen. 1 over 3 plus 1 over 5. What's the least common denominator?
3.
It's not 5. 3 doesn't go into 5. So what do you do? What number do 3 and 5 go into?
10.
Okay, 15. You can figure out a number they both go into. Sometimes you just multiply them together to get that. Okay. Now, what you were saying, generic student, is that because I can't say your name on the recording, right?
Generic.
NPC student over here, okay, is that sometimes you have to multiply them together to get the least common denominator, okay? But sometimes it is already there, just like this one, okay? There's not a hard and fast rule. Sorry about that. All right, example 4, y'all ready? There's actually 8 of them, but we're going to cross out number 8. I know, it's crazy. All right, example 4. Now, this is probably the most craziest one. So y'all ready to go crazy? All right, now, what do you think the least common denominator of these two is?
X.
X is wrong. Sorry. What'd you just say? 6x minus x minus negative 6, what? What'd you say?
Is it 3?
This? Okay, now x minus 6 by itself is not the least common multiple because x goes into x but not the minus 6.
So it's
Okay?
negative 6.
Negative 6 by itself? Negative 6x? No.
Negative 6,
No.
3,
No.
2.
So I want you to think about what you're saying though. Because you're trying to give me a polynomial expression that both of these go into. Okay? So this doesn't go into x. This by itself does not go into x minus 6. They're such distinct terms. Hey, student, that I was talking to earlier. What did I have to do with the 1 over 3 plus 1 over 5? What did I have to do with 3 and 5 to get the? What did I have to do? I had to multiply to get the least common denominator.
You have to multiply here too?
We have to multiply here too.
Oh my gosh.
You said it. Very good. So check it out. Okay, so here's what you do. Here's what you do. You're going to have to take this denominator times this denominator. It's going to look like this, literally. X times x minus 6. When they don't have an obvious common denominator, you're going to have to just put them next to each other and multiply them. Okay? Now, here's... No, just watch. Stay with me. Talk less and watch. Okay? Now, this first one, I need to multiply this by x. Okay? So I'm going to multiply the top and bottom by x to get my common denominator. This one on the right is missing the x minus 6. So I'm going to multiply the right one times x minus 6 on top and bottom. Okay? So again, you've got to multiply together. So whatever's missing on the left, multiply on top and bottom. Whatever's missing on the right, you multiply it on the top and bottom. Okay? Now let's do a little bit of math. On the top, x times 3 is what? Okay, 3x is correct.
Yes.
On the right, 2 times x minus 6. You're going to distribute. 2 times x is 2x. 2 times negative 6, negative 12. Okay? So I know this is the craziest one so far, but when you have two different polynomial terms that don't match, don't have something in common, you multiply times each other like this. A little bit. Now, next step, we got to combine like terms. 3x plus 2x gives me what?
5.
5x minus 12 stays there, and your denominator stays the same. Is everyone getting this down? Right? Right? All right.
You like that type of jazz? I hate jazz music.
Real quick, the bottom of the front page, you got a little bit of something to write where it says, what are the steps? So here's those steps. Okay, write this down, please, real quick, and we'll get to example 5 on the back. Okay, if you still need number 4, real quick, let me know when you're done with 4. There we go. Write these down at the bottom of the first page, please. So to add fractions, you find the common denominator, right? Hey. No, you didn't. Add the numerators together, and then reduce if needed. Okay. Okay, everyone ready for example 5? You do that one? All right, backside, number 5. We got 3 more examples and we'll be done here. Ready? What? No. All right, so what's different about this?
Everything.
Not everything. Subtraction, okay? So real quick, look at the first step. I know it's kind of cut off here. All right, look at the red. Ready? When you have a subtraction sign, make it a positive and move that subtraction sign up here. Okay, you're going to change this sign of this and make it addition. Okay. So the minus sign goes to the right term. Okay, it changes the right term. Now, who could tell me the least common denominator of 9 and 27?
27.
Okay. 9 does go into 27. How many times? 3 times. So, again, sometimes you do pick the bigger number. It works here, but not always, right? What's up? Let's find out. So, the first fraction, we're going to multiply by 3 so we can get to 27. So, 3 times 2 gives me 6. 6 plus negative 8 is what? What'd you get? So you think it's negative 2 over 27, but the actual answer is, oh wait, you're right.
Wow.
27.
He's a
The bad way? What does that mean?
Okay. Everyone got example 5. Okay. Does everyone see that you're subtracting? It's a little bit different. Let's try example 6. Here we go. Now, first of all, is it subtraction?
Yeah.
So the minus will go over here to this positive 5 and make it a negative 5. Do that real quick. All right. Hey, student on the phone, don't do that. Now, x plus 2 and x minus 3. What's the common denominator?
That one.
This one?
Yeah.
No.
That I was pointing at that one.
That one?
Yes.
No.
I was.
No. It's actually not on here. Like, if I have 2 different terms,
the whole time.
if I have 2 different terms, I want to know what they multiply to make. Sometimes they don't. They're not. Sometimes it's not on here, right? It's not just the number 6. It cannot just be a number because there's x's involved. X's need to be involved, right?
How do you know I wasn't pointing at the X?
Okay. Nothing on the screen right now is the answer.
That's what I was saying.
Oh, okay.
It was a trap the whole time.
So here's the deal. Y'all remember this? What I just asked y'all earlier? What's 1/3 plus 1/5? What did you have to do with the 3 and the 5?
Multiply.
Multiply. So guess what you're going to do with these 2 parentheses? Multiply. So check it out. When they are not common, when they're different, distinct factors like this, you're going to multiply them. So check this out. The first one gets multiplied by the second denominator. So x minus 3 on top and bottom. And then the second one's going to be multiplied by the first denominator, which is x plus 2 on top and bottom. Do you see how the bottoms now match? So when you multiply these binomials, now they match on the bottom, okay? Everyone's getting this. I know this is probably one of the more complex ones, but everyone's looking. No one's asleep. All right.
You need me to smack someone.
No. no.
Same. I would.
No. All right, let's do this. So first one, x minus 3 times 1 is going to be the same thing, x minus 3. What? Now, on the second one, we distribute the negative. Listen, we're going to distribute the negative 5. So what's negative 5 times x? Negative 5 times x. Negative 5x, thank you. And then negative 5 times 2. 5 times 2 is negative 10, okay? Do you see when you have these two binomials, if you multiply them by each other, the bottoms match now. Make sure you multiply correctly on the top, and now you can combine like terms. What's 1x plus a negative 5x? 1 minus 5, what do you get? 1x plus a negative 5x, 1 minus 5. Not 6. Okay, negative 4x, stop. Negative 4x, and then negative 3 plus negative 10 gives me what? Not positive. Negative 13, okay? So, when you have two negatives, only when you multiply, then they turn positive. But when you're adding, they stay negative. Now that's kind of tricky, right? Phones away, please. We're almost done. Now, this is our final answer once we combined like terms. All right. One more because we're going to not do example 8 because we've been doing this for already a long time. Of course. So, are we good on this so far? Okay, example 7, here we go. Now, let me remind you, y'all remember 5.0, what we did?
No.
Okay, look, a trinomial. Can't you turn this into two binomials? We can. We want to find the factors of that third term. So again, when you see a trinomial, let's find the factors of that negative 12. Okay, what multiplies to make negative 12? 1 times negative 12 and negative 1 times 12. What about 2? 2 times what? Negative 6. Negative 2 times 6. What about 3? Negative 4. Negative 3 times 4. These are all the factors of negative 12. Which one of these would add up to make the middle term 4?
I got it. Negative 1 and negative 12.
That does not make 4. What? 2 and negative 6 would give you...
Negative 3 and 4.
Okay, negative 2 and positive 6 add up to make 4. Okay, 3s and 4s would make 7 or 1, so no. So negative 2 and 6 give us 4. So notice this next step. First of all, we're going to turn that plus and turn that into a minus 1, right, on top, right?
Right.
And then we're going to break that trinomial into two binomials. Does everyone see that? This is not random. I got these two numbers by doing the factoring. Now think about this. If this first term is x plus 6 times x minus 2, and the second one is just x plus 6, no. Only when they're on top of each other. What do I do with these, or what is the least common multiple of both of these?
6. I got it. 6. X plus 6 equals x plus 6 on the other. Twins.
You know, I'm thinking as hard as I can here.
Okay, hold on. It's not just one number. When you have these x's, it's never just one number. Okay, so check it out.
Okay.
I am multiplying these two together. This one just has this one. So what is this missing to match this?
Negative 2.
X minus 2.
Yes.
Okay. So do you see how this is two terms? Sorry, two factors. This has one factor. So this one is missing an x minus 2. So if we can just multiply this right side by x minus 2, they would match, right? Like this, watch.
So we can just create that variable. We don't need
Like if they have one in common, then the one that's missing, you're gonna multiply it on the other one. Okay. So we're gonna take that right side, -1 times x plus, yes. Not this big. -1 times x and -1 times -2 gives you -1x, and negative times a negative is a +2. And then we can combine like terms. So what's 7x plus a -1x, or 7 minus 1? It's a -1.
That's less than 0.
7x plus -1x. 7 plus -1, or 7 minus 1 is 8.
The answer is
Somebody help me. 7 minus 1 is what?
6.
Thank you so much. 6x.
5.
And then plus
Yes.
2.
I knew it was 5.
So notice we combined like terms. The 7x plus the -1x gave us 6x. The plus 2 comes down. The denominator stays the same. Okay. The main thing you got to notice about all these is that the denominator must match. The tricky part is how to get that same denominator. I know these are a little bit tricky, but we've done 7 examples. Okay. Does everyone have 7 down?
Now, if you will,
Who does not have 7 down?
then you explain to me
Okay.
how to subtract fractions.
That was 5, 6, and 7. That's what we did.
Yes.
It's basically turn it into a plus and then add them,
Mm-hmm.
the way we did the front side. Real quick, 8, go ahead and mark it out. Skip that. And then, last but not least, look at this last part. Heck. Okay, write these down. In your 8.3 assignment I'm about to give you, you're going to do numbers 1 through 10. Okay? And that'll be that.